for g of theta, we've got this tangent function, and then we've got over here, this inside piece is what we're looking for the phase shift. So phase shift, remember, is our movement left or right. And it's the movement left or right of the y-intercept. Okay. And the reason that we do this, that we figure out how far the y-intercept moves, is it helps us determine roughly what the graph is going to look like. So what I would normally do is I got to look at two things. I got to look at this back number and the number in front of the theta. Now the number in front of the theta here is just a 1. So what I would do is I would take the back number and I would divide it by the front number. But when you take a number and divide it by 1, you just get that number back out. So pi over 2 is our movement. Now the question is it left or right? Since this is negative, it's a movement to the right. You do the opposite of what you would think. So this is going to take our tangent function and move it to the right. So our phase shift is to the right by pi over 2, which is 90 degrees. So let's take a look at what that's going to look like graphically. Okay, so let me pull up Maple here, and let's go from, I'll go from negative pi to 2 pi. That's fine. So our first function that I want to graph is our tangent function, and that's going to be, let's do tangent x minus pi over 2. And let's make that blue. And then let's also just plot the tangent function in general, so which would be the parent graph, and that's in red. So the red graph, this right here, let's make the discontinuity true, meaning that when I say discontinuity, true, what I mean is I don't want to see the vertical asymptotes, and so I can tell Maple to not put those in there. So here's the original tangent function. That's what that guy looks like. Now if I take that guy and I move this right here over pi over 2, because that's what, if you look back here at our notes, I've got a right shift by pi over 2. So what I want to do is I want to take this point right here and we want to move it to the right by pi over 2, and that's what's going to happen when I graph that new function. So notice the blue function is a right movement of this point to here by pi over 2. Now because the value in front is 1 and we don't have any horizontal shrinking or stretching, every point is going to move over by pi over 2. So notice that the whole graph moves over by pi over 2. In fact, if I don't graph the original function now, I just graph the blue one, notice that I've moved my tangent function over by 90 degrees, or pi over 2.